If you want to calculate Q or C, they both have the same equation. Q or QC or K, these are all constants. The constant of equilibrium, or what's known as K equilibrium, or it's known as Kc if you are talking about concentrations, or Kp if you are talking about partial pressures, is calculated the same way as Q. If you have an equation like H2 plus I2 give you 2HI, so to find any of this, you need just to make equilibrium. The products of the product, this is the products. So I have one product here, which is HI, and since this is K equilibrium, then I don't know yet which one I will use. If we are talking about Kc, then this is the equilibrium constant for the concentrations, either for aqueous solutions or gases. And if it is Kp, it is the equilibrium constant for the pressures, and this is only for the gases. If you are talking about the concentrations, then instead of K equilibrium, it will be Kc. So I have two options for K equilibrium, either Kc or Kp, two options only. In the Kc, I will put the concentration of the first product divided by the concentration of the reactants multiplied by each other and not added. So I have here H2 as the first reactant and I2 as the second reactant. And every one of these will be raised to the power of its coefficient. The coefficient of Hi is 2 in this balanced equation. So I will put here Hi to the power of 2. This is coefficient 1 and 1. So here power is 1 and 1. And of course, we don't write 1. If you want to find K, P, you will do the same thing, but this will be for gases. So you will, instead of saying a bracket, you will write Hi also again, H2 again, and I2 again. The only difference is that you don't write this, because this one bracket you write for the concentrations only. So you write the P here, pressure, pressure, pressure. And also it will be to the raised to the power of its coefficient. So I will write pressure, 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 and everyone will be raised to the power of its coefficient. Coefficient again is 2. What about Q? Q is found in the same way. The Hi, either QP or QC, Hi squared divided by H2 and I2 squared. So what is the difference? I mean to the power of 1. So what is the difference between Q and K equilibrium, or Kc and Kp? I find that you find it the same way. We have in a reaction which is at equilibrium, any reversible reaction happening in the forward direction and backward direction. So I have three options. Either the forward direction is faster than the backward, or the backward direction is faster than the forward, or they are both equal. So in this case, I say that this reversible reaction is at equilibrium. If you are having the reaction at equilibrium, so this value, when you divide it, you will find the K equilibrium, either Kc for concentrations or Kp. If you are not at equilibrium, if you just started the reaction and you don't have products yet, so there is no way the backward will be equal to the forward, then you are at the forward faster, so you are still measuring the Q. And if the backward is faster, also you are just measuring the Q. To mathematically find the QP or the QC or for any equation, you just plug in the numbers. So you find the concentration for Hi, square it, and then divided by the concentration of H2 multiplied by I2. And if you are talking about the pressures, then you find the partial pressure in atmospheric pressure units or whatever unit divided by the pressure of H2 multiplied by the pressure of I2. If you are trying to find the Q, you will do exactly the same. The only difference is that you will be asked to find the QC or QP only if you are giving the concentration or the pressure at equilibrium point. But if you are not giving it at equilibrium point, so at any other point in the reaction or at any other time where there is no equilibrium yet, it will be called the Q. So basically, if Q is equal to K, you are at equilibrium. If the Q is more than K, you are moving backward mainly because the backward is faster than the forward. If the Q is less than K, so mainly the forward reaction is faster than the backward reaction. How can I find the initial concentrations, change it into the equilibrium concentrations if I don't have the equilibrium concentrations. Like I am asked to find the concentrations or the pressure at equilibrium in order to find the K equilibrium. But I don't have them, I have only the initial concentrations. Then you have to construct something called ice table. Just write your equation, write it balanced equation, and then check which concentrations he has given to you. He has given you the initial concentrations. So I stands for initial. And you don't need the initial concentrations, you need the final ones, the equilibrium ones. So E stands for the equilibrium. So you just need to know what is the difference between the initial and the equilibrium concentration. The difference or the change that happened is what's known as C. So you are talking about ICE table. The ICE table is the ICE table which helps you to find the difference between these two. And in order to do so, usually you are given some concentrations, or in case of pressure, you are given some pressures. So if you are given H2 concentration as 5 molar, and this is as 5 molar also, but you don't have any concentration for HI initially, so you know that this one has most probably decreased. In most cases, you will be either given the K equilibrium and asked for one of the concentrations, or you will be given all the concentrations and ask it for the K equilibrium. So in this reaction, since this is not a reaction that goes in one direction, so you are not sure that the reaction forms how much of the HI, you don't know how much of the 5 mole or molars has been decreased. Since these are reactants, this will concentration will decrease, but I don't know by how much. And this one I don't know. If the ratio in the number of moles is 1 to 1 here, so most probably if this is minus X, this will be also minus X. So the amount decreased from the H2 is the same as the amount decreased from the I2 because the ratio is 1 to 1. And since these are products, so the concentration will be also increased, but in this case, it will be increased by 2x. Why not by x? Because the ratio is 1 to 2. To find the equilibrium concentration, you have just to make the difference between the 5 molar and the equilibrium. So equilibrium is basically the 5 decreased minus the x. And this is 5 also decreased minus the x. That was 0 and it decreased by 2x, so that's 2x. So you can find the x concentration by two methods. Either he is giving you the K equilibrium and you are asked to find one of the concentrations, or he will be requiring the K equilibrium, but he has to give you one of these values. So for example, he will tell you that at the end of the reaction, I was finding that this is equal to 10 molar. So if this one is 10 and this one has increased by 2x, so this one has increased by 5 because 2 multiplied by 5 is 10. So that was 0 and it increased by 10, so it is 10. This means that the x is equal to 5. So 5 minus x is equal to 5 minus 5, because we know from here it is the same x value, which is 5. So 5 minus 5, this becomes 0 and this becomes 0. This will help us to use the same equation for the KC to find any value required. A very small example is when I have the same equation, H2 reacts with I2 to form 2HI. I say that I have been given 1 mole of H2 here and I2 started into a 2 decimeter cube container at 490 degrees Celsius. Find the equilibrium concentration. So you need to find the concentrations at the equilibrium point. So what are these concentrations? The concentration is found by finding the number of moles over volume. I have the number of moles here and I have the volume. So I can just divide 1 over 2 every time to get the concentration of 0.5 molars. And this one is the initial concentration because this is what started the reaction with. He didn't say that I started with any of the HI. So here is 0 moles and the concentration is 0 molar. This is not the equilibrium concentration, so we cannot use this for the equation of the K equilibrium or the Kc. It said that the Kc value here is equal to 45.9, or it said K equilibrium or Kc is equal to 45.9. So this 45.9 is equal to the concentration of the HI squared divided by the concentration of HI and I multiplied by each other. But wait, we don't have the concentrations because we are looking for the concentrations at the finally at the equilibrium, not at the initial. So we need to find the change that happened. If this one is 0.5 and it has decreased by x, and this one also decreased by x because the ratio is 1 to 1. So as we said, this has to be increased by the value of 2x because the ratio is 1 to 2 here. So 0.5 minus x and 0.5 minus x, we got this by adding these two together, and 0 plus 2 means 2x. So you are saying that the HI squared, which is the concentration at equilibrium, which is 2x squared, if divided by the concentration of H2 and I2 multiplied, which is 0.5 minus x, 0.5 minus x, is equal to 45.9. So using any simple calculator or even by math, I can find that the x value is equal to 6.8. And this means that this x is equal to 6.8. So I can, I'm sorry, this is equal to, let me do it again. That's equal to 0.39. So if 0.5 has decreased by 0.39, this means that what is remaining is 0.11. And here also 0.11 has remained from the 0.5. And this is 2 multiplied 0.39, so that 0.78 has been produced. Now you are saying that this 45.9 is equal to the 0.78 squared divided by 0.11 multiplied by 0.11. So have all the values, what is found? What's required to find? You found it already. You find the x, which is the concentrations initially and at equilibrium found. This is 0.11, 0.11, and this is 0.78.